Okay, so today we are going to build a small project using a vision language model, and we are going to be using some GPUs for it. So I'm basically using Google Colab. Now here, if you go to runtime and if you basically click on change runtime type, you will be able to select the runtime type. So basically what type of a language you want, and select the hardware that you want. And in this case, we are basically using T4 GPU. Now, one of the things is just like how you have a task manager, right, in Windows or Mac, especially when you're using GPUs, you have something called as an SMI, right, which is a system management interface. And the way we could basically check if that is actually working here is by typing NVIDIA SMI. And let's just run this. And what this basically tells us is that it tells us that this is a GPU that is available. So the next step here is basically to install a package called as VLLM. So you just type in pip install VLLM. Let me just put the version number real quick. So you might be wondering why we need this. To put it in a very simple way, whenever you want to basically use a large language model or a vision language model, you call that step as inference, meaning you're actually using the model, right, to get some results. Now you could basically build your own inference framework, but it is going to have a lot of problems. And that is why we are actually using this library or package called as VLLM, and that lets us use any large language model that we want in a very efficient way. All right, so let's go ahead and install this. Okay, so now you can see that the installation is complete, but we have a couple of issues here. But these issues are not relevant for us. There is actually a conflict with packages that come pre-built with Google Colab, which we don't care about. So this is a message that we can totally ignore. Now, one thing that I can do here is I can quickly add a new code block and type in VLLM version, and what this is going to do is it's just going to execute and tell me what the version of VLLM has been installed, and if that works, that kind of tells us that the installation went through. Yep, so here you can see that the version number is getting printed, so we are all good. And for the choice of model, we are going to be using this particular repo, dots.ocr, primarily because this has been getting a lot of attention these days, right? Very, very popular. And if you go through this repo, I'll make sure that I pin it in the comment. It's scoring good on a lot of benchmarks. Now, I personally don't really worry a lot about the benchmark scores. What I primarily look at is examples of what the models can actually do, right? So here, if you basically see, this is an example where it is actually parsing math equations, right? Now, obviously, we'll have to fact check to see if the equations are being reproduced, but that's kind of what the benchmark tests. It looks at tables and then sees if the tables are being captured correctly. Now, this is obviously in different languages, older books, and this seems to be what, like almost like a test. And this is what I'm very much interested in. So here you can actually take in original images, and this lets you convert or generate the images again. And this, I think, has a lot of applications, and this works for SVGs as well, right? So here you can see that it is generating an SVG based upon, an image, which I think is very, very exciting. Now, when it comes to using the model, typically we rely on Hugging Face. For those of you who are not familiar with what Hugging Face is, let us say you want to use an LLM. Typically, that means you are basically downloading the model, which means the weights of the model. And these tend to be huge. So typically in the order of gigabits, right? And you could actually get that from Hugging Face, and you can just integrate that with your application. Now, in this case, we're going to be using Google Colab, and VLLM, right, the library directly interfaces with Hugging Face, and that is what we are going to do next. So we have everything we need, and now I can just copy this command, right, which will basically help me serve the model. So let me just go back to my OCR, right? I've ensured that everything loads correctly, and I'll just paste it here. Okay, so now let's break down this command. So VLLM serve, what it does is it serves this particular model that we have. And here the tensor parallel size is 1. We are essentially breaking down that model into 1 GPU because that's all we have access to. GPU memory utilization is 0.9, which means we can use up to 90%. I think that's a good start. The chat template content is string, that's just a default, so I will just leave it as is. Served model name is the name that you want to provide. We'll just call it as model. You could just give it any name you want, and trust remote code. And on colab, if you just put an exclamation, this would just get executed. And that's basically it. Let's just run this. Now this command will take a lot of time to run. And one thing that I would ideally do is basically open this particular resource bar and keep an eye on your GPU utilization. Alright, so it actually failed, and here you can basically see the error. To serve at least one request with the model's max sequence length, 3.5 gigabytes of KV cache is required, and this is all we had, 2.43, right? And that's why it actually failed, and you can see that the GPU memory has flatlined as well. So I was able to serve the dots.mocr model successfully by adding this single parameter, max model length. So now the model is running, and typically when you run it on Google Colab, it basically runs on this particular endpoint. And if you pass an image to this endpoint, and if you basically give a prompt, it will extract the information from that particular image. I'm choosing this image. This is done by my kid. On the left hand side, you have computer generated questions. On the right hand side, you have a real human handwriting. I want to see if the AI, if this particular model can recognize. So I ran this, and here are the results. It was able to recognize the 7 questions. Here, for those of you who are not familiar with this is what you will call as latex. And it was able to get the left hand side correct, but the right hand side, except for the last one. So here you can see the right hand side is 3. And then if you go back to the image, the right hand side is 3 as well. So it got that correct. But if you take the first equation, the right hand side is 2 by 3, whereas here the right hand side is 3 by 3, which is wrong. So that basically concludes this project. So the next ideal step would be to rent out a GPU, have this model in place and make sure that it's up and running, and then expose the endpoint right publicly so that we can integrate this with an application. And here, a couple of things that I can think of is, imagine that you're scanning the assignments submitted by children, and then you use this model to grade it, and then we need to ensure that there's a manual review process. And once the manual review process is done, you could actually use an off-the-shelf LLM, right, to grade the assignment as well, and then finally print that back on the paper and then send it to the student. That is kind of an application that we could actually run. And I think the model is small enough that you could have this engine run for unlimited evaluations for say $20 per month, which if you think about it is quite cheap. Obviously, I'm not going to be building that piece because I think we have enough proof of concept here, and if that is something that you are interested in, feel free to try it out and let me know how it goes. All right, see you in the next one. Bye.